Dear friends, again welcome to the annual refresher program in teaching commerce titled Financial Markets and Emerging Business Models offered by the UGC-HRDC University of Kerala. Dr. Santosh Kumar, Professor of Finance, School of Management Studies, Cochin University of Science and Technology, Kerala, is on board for sharing one of the fintech innovations, blockchain, which is becoming popular day by day. It is emerged as a catalyst along with artificial intelligence, Internet of Things, and virtual reality for the fourth industrial revolution we are witnessing now. In this module 3.2, we will look into what does a blockchain mean, what are its features, what does a block contain, how does it work, how transactions are validated in a blockchain, and what are its applications to revolutionize the traditional value chain in the delivery of products and services and the emerged business models out of it. Blockchain is a revolutionary technology which came along with the cryptocurrency Bitcoin in 2009. It is the brainchild of a person or a group of persons with the pseudonym Satoshi Nakamoto. So, what is a blockchain? All of you will know a ledger. Simple. A ledger is an account book. Like that, a blockchain is a digital ledger of economic transactions that can be programmed to record. It is not just financial transactions, but virtually everything of value can be recorded into this digital ledger. In short, blockchain is a concept of storing data digitally. This data comes in blocks. That's all. So, a Bitcoin blockchain means a digital ledger which records Bitcoin transactions. A bank blockchain means a blockchain which records transactions happening in a bank. A healthcare blockchain means a blockchain which maintains the healthcare records of a group of people. A landholding blockchain means a digital record of land holdings and the transactions on it. As the name indicates, it is a chain of blocks which records transactions. It is a public digital ledger because it is open to all the participants in the network of computers. Decentralization, transparency, and immutability, which brings trust and security for the participants in the network, are the three important characteristics of a blockchain. What does decentralization mean? When you Google search for something, you send a query to the server who then gets back to you with the relevant information. This is simple client server. This is how a centralized system works. In a decentralized system, information is not stored by a single entity. Everyone in the network owns the information. There is no third party here. You will get more clarity about this aspect when I explain how a blockchain works. Another important pillar of blockchain is transparency. In a blockchain, a person's identity is hidden through a complex cryptography and the person is known in the network by a cryptographically made public address. So without disclosing a person's real identity, he can do all the transactions using his cryptographic public address. This is the level of transparency in the blockchain. This has never been existed before in any financial system. Once you record a particular transaction in this digital ledger, it cannot be tampered. The reason why a blockchain gets this property is that of its cryptographic hash function. If you make any change in the data in a block, it will make invalid all the other blocks in the chain. Though it sounds complicated, really it is not so. What does a block in a blockchain mean? A block in a blockchain is a container of validated transaction records. In other words, it is a bunch of transactions that have been added to the blockchain. Each block can be thought of as a page in a ledger or in an account book. Each block can contain a number of transactions. What are the elements of a block? In simple words, inside a block, there is data, hash, and hash of the previous block. Data are the details of the transaction. For example, in the case of a blockchain which records transfer of money among the participants in the network, the details of the sender, the details of the receiver, the amount involved in the transaction, and the date stamp of the transaction are the data in a block. Another element of a block is hash. It is the security aspect of a block. Data are kept in a block using cryptography. That means if A sends money to B, that transaction is recorded using cryptography in a block. The encrypted form of the transaction, as shown here, will be stored in the block. So, hash is a function that converts an input of letters and numbers into an encrypted output of a fixed length, which is also alphanumerals in nature. It is created using a computer algorithm. Hash is like a solution and is the backbone of the blockchain network. In short, the details of transactions are in a block in its hashed or encrypted form. In addition to the hash of the block, the hash of the previous block will also be there in a block, which facilitates the immutability feature of a blockchain. Hash in a block is highly sensitive. Once you tamper a block, it will change the hash of the block as the hash pointer in each block, which connects with the previous block, will change the hash of the other blocks, making all the other blocks invalid. Therefore, tampering a block is almost impossible. Now let us understand how a blockchain works. Here is an example of a blockchain for transfer of digital money. This is a computer network of 4 participants, A, B, C, and D, with blockchain technology for recording transactions among them. I am just putting up a block there indicating that Mr. A in the network or blockchain has a digital money holding worth 50. So a block is there showing the holding of Mr. A. In short, it is a computer network of 4 people wherein one block is there showing the holding of digital money worth 50 by one of the members in the network. Then Mr. A wants to transfer this digital money worth 50 to B in the network. So immediately another block will be added to the network with the transaction details to effect such a transaction. Again, Mr. B wants to transfer some digital money worth 25 to C in the network. So immediately another block will be added to the network with the transaction details. Then Mr. C wants to transfer some digital money worth 15 to D in the network. So immediately another block will be added to the network with the transaction details. Assume Mr. A again tries to transfer the same money worth 50 to D in the network as the money is in digital form. If you have something in digital, for example, an email message or a WhatsApp message, you can send the message to different people. This multiple spending of the same money is not possible in a blockchain. So, a double spend is an attack where the same money is spent twice or more. Blockchain technology offers double spending attack protection. Friends, look here. Everybody in the network has the same record of transactions, which is simultaneously reconciled. That is why a blockchain is called a distributed ledger. It is open or public ledger in the sense that everybody in the network has access to the same ledger. And more importantly, a blockchain is a peer-to-peer managed digital ledger. So, no central authority in the network. This feature of blockchain is called independence, means independent of a central authority. Then there is a question, who is making and adding blocks in the blockchain network? Since blockchain is a peer-to-peer managed one, no one is there as a central authority to add blocks into it. The process of adding a block to a blockchain is called transaction validation, which is as same as consensus of all in the network. It means that only validated transactions can be stored in the blockchain. In a public blockchain like Bitcoin, transaction validations are done by miners in the blockchain network. Miners are computer nodes with supercomputing power. With their supercomputing power, they will solve a cryptographic puzzle to get a turn to add block into the chain. This is done by them for getting some economic rewards or benefits. In the Bitcoin network, the reward is Bitcoin. The process of solving the crypto puzzle is called proof of work mining. Proof of stake is another method for transaction validation and consensus. In proof of stake, validators will be chosen on a random basis by the blockchain protocol based on their stake in the network in the form of money or money's worth. More details about mining will be dealt with in the next module. Now let us come to the discussion on emerging blockchain applications. Applications of blockchain have multiplied well beyond the financial sector. The use of blockchain ranges from the sharing economy, smart contracts and digital voting to management of logistic chain. The areas of applications thus surpass economic sectors, and the blockchain is already on the brink to transform all existing industries. This technology is set to radically change the organization of transport, the supply chain, advertising, energy production and distribution sector, the real estate market, insurance, and so on. It is going to transform the future, taking us from Internet of Things to autonomous objects. Let us have a look at the applications of blockchain in different sectors. One of the sectors where blockchain can be applied for improved functioning and customer experience is the financial services sector. The World Economic Forum considers blockchain as the heartbeat of the financial sector. More and more financial services are using blockchain technology to introduce innovations such as smart bonds and smart contracts. In the financial services sector, use of blockchain for providing domestic banking and payment services are exponentially growing. Traditional systems tend to be cumbersome, error-prone, and slow. In contrast, users find the blockchain cheaper, more transparent, and more effective. The blockchain technology can provide banks with efficiency, speed, security, and reduced costs in many of their processes. This will directly result in both a price reduction and improvement in the quality of services for the end users. Similarly, the global payment sector is also error prone, costly, and open to money laundering. It takes days for money to cruise the world. The blockchain technology can provide solutions for this problem by linking the service with remittance companies that offer end-to-end blockchain-powered remittance services. Now there are banks with blockchain payment applications that enables customers to make international payments 24 hours a day. Asset management is another financial service where blockchain technology could be applied effectively. Traditional security trade processes as part of asset management can be expensive and risky, particularly when it comes to cross border transactions. Each party in the process, such as broker, custodian, or the settlement manager, keeps their own records, which create significant inefficiencies and room for error. The blockchain ledger reduces error by encrypting the records. At the same time, the ledger simplifies the process while avoiding the need for intermediaries. Insurance is another financial service for which blockchain technology suits well. Traditionally, claims processing can be a frustrating and thankless procedure. Insurance processors have to stride through fraudulent claims, fragmented data sources, and process manually. Therefore, chances of errors are huge. The blockchain provides a perfect system for risk free management and transparency. Its encryption properties allow insurers to capture the ownership of the assets to be insured. The blockchain technology can codify business rules and automate claims processing through smart contracts. Cybersecurity can be ensured by blockchain technology. Blockchain technology can be used to prevent any type of data breaches, identity thefts, cyber attacks, or foul play in transactions. This ensures that data remains private and secure. Supply chain management is possible by applying blockchain. The real time tracking of a product in a supply chain with the help of blockchain reduces the overall cost of moving items in a supply chain. Payments can be processed by the customers and suppliers within a supply chain by using cryptocurrencies rather than relying on electronic data interchange. Blockchain supported sharing economy is fast emerging. A protected connection to vehicle data and functionalities can be established using blockchain. This shared ledger technology will enable secure and transparent in-vehicle payments so that motorists can pay for tolls, parking, car sharing, and e-battery charging on the go and receive payments for car sharing. Online data storage can be possible using blockchain technology. It is a solution to make the cloud storage faster and more secure. The blockchain ledger is encrypted such a way that only authorized parties can access the data. Since the data is shared, the records cannot be tampered. Charity collection is possible using blockchain technology. By minimizing administrative costs through automation, providing more accountability, and allowing donors to know more clearly where their funds are going, the blockchain technology may help to restore some of the lost credibility to the charities that prove worthy of public's trust. Using blockchain, vote casting can also be done efficiently. The votes could be verified right after the voting is finished so that officials can be certain that the votes are counted correctly. This can be achieved without the need for a central body overseeing the results as we currently have in the system. As such, any vote that is counted has to be completely verified, fully ensuring that there are no security breaches at risk. Governments can very effectively use blockchain technology for governance, secure storage of citizen and business data, reduction of labor intensive processes, and excessive costs, reduced opportunities for corruption and abuse, increased trust in government and online civil systems are possible through blockchain. The blockchain technology has the potential to transform the healthcare sector. Placing the patient at the center of the healthcare ecosystem, blockchain technology could provide a new model for health information exchange. Energy management is another area where blockchain application is possible. Blockchain enables real-time coordination of electricity supply and demand data that can improve demand-side energy efficiency. Blockchain solutions can also be used to accurately monitor and control energy performance in real time, which will ultimately increase supply side efficiency. In the music industry, blockchain technology can bring artists and fans closer together, allowing listeners to pay micropayments to artists for listening to their songs directly. Blockchain technology can help retailers to improve how they store information about their suppliers, help seamlessly execute payments and contracts, and even reinforce product authenticity to prevent counterfeiting of goods. Real estate transactions are often conducted offline, involving face-to-face engagements with various entities. Blockchain, however, opened up ways to change this. The introduction of smart contracts in blockchain platforms now allows assets like real estate to be tokenized and be traded like cryptocurrencies such as Bitcoin or Ethereum. Crowdfunding is possible using blockchain. Blockchain allows for transparency, thereby allowing the investors to be fully aware of where their money is exactly being used and not to depend on a third party. Blockchain also facilitates smart contracts that allow two people on the internet to know their agreement terms and not to depend on a third party. It is quite evident from the above discussions that the blockchain could become a powerful technology for improving business, conducting fair trade, democratizing the global economy, and helping support for more open and fair societies. It can be applied in almost all fields. The coming era would be a blockchain-based one. Thank you for watching this module of blockchain. Have a nice day.